I'm Leonardo Camacho, and this is Jay John Brito. We worked on the school boss app. We work for the Sonification lab.
So the Sonification Lab is one of the nice labs at Georgia Tech, led by Dr. Bruce Walker. It kind of combines different things like design, psychology, engineering, computer science into one lab to make the best of everything.
So basically, our project was based on the problem that several parents and schools face day to day, which is taking the schools to school. They face the problem of not knowing where exactly the bus is at, if the bus has already passed by, if they're still waiting for it, and all of this is still being worked manually by the school districts. Therefore, we're proposing a new solution to it, which is using the technology that the buses are collecting right now in order to provide a good service to all the stakeholders, which in this case is the school district, the schools, the bus drivers, and the parents, all into one single app. We focus mostly into the development of the parent side, though.
So like Leo was saying, there's going to be different apps for parents, different apps for people on the school side, different app for the bus driver, and kind of like a different app for on the high level that are in charge of the entire county. And we're focusing mainly on the parent app, like Leo was saying. But one thing I want to mention, that this project is different compared to like other bus apps that are existing or coming to development is I like to mention that again, Sonification Lab is a lab that has a bunch of different disciplines like psychology and design. And even though we're going to show you kind of like a demo of this app, there's been many semesters and multiple years worth of just researching with parents, um, school people from school side principals, teachers, and also bus drivers gone into making this app, and that's its biggest advantage. So like everything, there's a reason why everything's laid out in a specific way. It's to make sure everything's intuitive.
Exactly. So this semester, as Jay already said, we are focusing our efforts into the parent side, specifically the chatting part of the application and the dynamic part of it. Uh, Also because all these different teams have worked before us, our main goal was to put everything together. We were the glue to the project, which is why we developed the back end of the application using databases and servers, which we're gonna go through the rest of the application of the demo.
All right, we're gonna start it with kind of like a high level overview of what we did this semester. So this was kind of our plan going in. Um, so the buses in APS or Atlanta Public School Systems, they have a device called Zonar that's implemented in every bus that kind of has a GPS location of every bus. And so we kind of want to use that as a data collection tool to see where a bus is at. And the goal was to take all that information and host that data onto a MongoDB server or any kind of similar database system. And we're going to host it on some kind of cloud service like Google Cloud or Amazon Web Services. And we're going to take that once we've built out that database, and we're going to connect it to our app using a system called Express. And Express kind of acts as a server, kind of like an in-between, and it has abilities to collect all the API calls from the server and using, depending on what kind of API call, to determine what kind of data to get from the server and return back to whatever app is being used. And as you can see right here, the app is built using React Native, that app. And additional thing we did was the chat. And we used two main things for the chat. The chat UI was built using ChatKit. And the chat server, where it's getting all that messages and getting it all stored, we're using something called Pusher, which kind of handles all that for us.
Yeah, so the first thing that we had to focus on was the database handling. We obtained some information from APS, which is Atlanta Public Schools. They collected this data from Sonar, and we decided on compacting all this information into a workable demo, which is why we just took one part of it as we work it with Python, and that's how it looks. We got two roots, the 530 and the 578, I believe. Okay.
And so what we did was, since we were working with React Native, the reason we used all this is we took all that data from the CSV and kind of compacted into a nice JSON format that we can use. And we did this so we can load this into MongoDB, which allows you to store those data as a JSON, which also makes it easier to get that data back. So one thing I'm showing you right here is we actually have all this data kind of hosted locally on our Mongo server. So this just started Mongo, and let's see. Okay, so let me just show where we're having our data. So this is kind of the data that we just showed you. And I know this seems like a lot, but this is kind of how we structure the data in CSV, and kind of a high level of how it's kind of being stored in this is kind of being seen here. This was kind of like our initial design for how we want the MongoDB to be. So we kind of have like a parents table, which has all the parents in so school, and parents will have like these are all my students kind of attached to a certain number of parents have children, so that they're going to have the students linked to it. They're also going to have their address, and they're going to use the address right here to determine which bus routes are going to be there, because an address, a person could either be in an elementary, middle school, or high school, so we need to know which route it is going to be in. And then this right here kind of ties into like the exact location of the bus using Zonar data. And another thing we have is schools. So each route is tied to a different school, so we have all that. And this right here, the bus route kind of has all that information. So each bus can be linked to multiple bus routes, and kind of tells you which part of the day it is. Is it during the morning route, the evening route, and also like the schedule time for each route. All that information's in there. And this kind of gives us more information on bus status. So is it on time, delayed, or is it early, or is it parked at the school? This has all that information. So this data is kind of representative of all that. And another thing we did is, so this is just localhost, and one thing I mentioned before was we want our data on the cloud. So we use something called MongoDB Atlas, which is another free service that lets us host essentially what we have locally onto this cluster. And another thing about this cluster is this kind of gives you 3 endpoints to hit. So just in case this data is on the cloud, if multiple parents are trying to hit it, if one cluster is busy, it can go to a second cluster. So this is like a really nice aspect of us having this data on the cloud. And next, we're gonna talk about Express.
Now, going into Express, we decided on putting a server locally in order to get the data from it in a more organized way instead of getting all the data all at once and then handling it. We now take the data from the server, and from there we can actually display the necessary information for the user in the front end. So how the server works, as you can see, it is running right now in 3000. We have it here. This is the get location um, part of the server, and this is the get data. As you can see, this is the same one as the one that Jay showed you before from the MongoDB. And this get location is actually the route that the boss is gonna follow. Right now, it's taking the, well, we can specify a location, uh, which of course can be updated from the front end. So right now we're gonna take the first point that we had using the latitude and the longitude. Using this, uh, we are gonna get the next location, which is, as you can see, the second item in our array. You can compare them. Uh, this is important as it allows the user to know the current location of the boss and how far is it from the next one. This can be used in this way in order to make it dynamically. And apart from that, Jay is gonna talk to you a little bit about the chat.
So again, one thing before we go on to the next thing. So right now we're using localhost because it's reliable. But you can see right here, if they uncomment this out, this refers to the MongoDB on the cloud. And we're not doing that because we have a limit on how much API calls we can use and how much money we can spend on that. So as of right now, we're just using localhost. So again, right here, we're doing chat, and we're using something called Pusher. So this right now is kind of like all the updates that we've gotten from the school itself. And this is being tracked using something called Pusher. And pretty much what we have right now, this parent is just John Doe, and as right now we just have ID parent. And you can have multiple rooms, so we're talking about different stakeholders, such as you can have a different room for just people in the school system. You can have a different room for administrators. You can have a different room for just bus drivers. So since there might be different apps, you can send out different kind of messages. And you see right here, bus has arrived. The bus is delayed by 5 minutes. Both of these were sent through this, and we received from our app. Let me just do another message. Just for demo purposes. So bus is starting from school. And look, our thing is dynamic and it's changing according to that. So that is this is a really great tool. It kind of like made implementing the chat a lot easier. And the biggest reason we chose this was it was very easy to implement with React Native, and it was very supportive of that.
So I think our next steps for the project will be to keep doing some data management. One of the problems that we faced was not getting the API to work from the Sonar database, which limited us to using only files that were exchanged through APS. However, I think the main objectives that were the chat and making the map dynamic were accomplished by using MongoDB and Express and Pusher, and
And I'd say the next steps would be like this. We have the parents app very fleshed out. So there's has been a lot of UI designs for this app used for the school, and also there's been beginning designs for app for the bus drivers. So kind of making those apps would be the next step. And the best thing about this is since we kind of laid out a lot of this backend, they can use the same MongoDB to construct that and also build additional tables on top of that. And another thing I'd like to mention is I believe a lot of people are interested in making this kind of demo or this app that we kind of made for this class into an actual company or actually funding this. So there's been talks of that. So that has been very successful. And there's future plans for making this, I'd say,
profitable.
yeah.
Thank you, thank you a lot to the Sonification Lab, to Amanda Chow, which was a PhD who instructed us in how the routes were built by the APS, to Luis and Mika by building the awesome design for the parents app and the rest of the stakeholders.
And also thanks for Dr. Walker for letting us work on this and also giving us advice and guidance along the way. And we'd also like to thank Abhi
Abby
and Kenzie for working on this app the previous semester. And also a big thanks for anybody, other students we might have missed out or just haven't had a chance to meet who also worked on this kind of things and this kind of app from previous years and previous semesters and previous iterations of this class.
Yep.